This is Group Cleaning Robot, formerly known as Vacuum Robot. We are going to present to you our design for hands-off cleaning.
Okay, so for our mechanical design of our robot, it's a rectangular bracket with about 4.4 millimeter thick walls with an overall size of 140 by 200 by 90 millimeters. We also have flanged sides with 3 millimeter diameter holes so that we could mount motors, the pico board. So our frame was specifically designed to accommodate the motors, wheels, and the weights. So the weight itself of our stock parts, being the frame, wheels, and motors, was 0.26 kilograms. But once we started adding our batteries, sensors, drivers, and motors, and the pico board and the wiring, it all slowly increased. So to find our max capacity, we first found our force of rolling resistance, which was 0.113 newtons, and then the torque applied to our wheels was 0.002 newton meters. And then we found the torque output from the motor, which was 0.03295 newton meters, but we upped the voltage from 3 volts to 7.4 volts, so we got a result of 0.0814 newton meters. And using that, we could calculate our max capacity, which is 1.239 kilograms. And that did fit with our robot, since our robot weighed far less than 1.239 kilograms, and that let us use up more, or it gave us access to more power. So our robot has some leftover wiggle room to accommodate more weight on it, in case we wanted to add something else on it.
So for our sensor selection, we chose a gyroscope where it would detect if there was a change in rotation and vibration. And it's basically a safety feature that would stop the car after an impact and stop the code essentially, and it would just end it and stop it from moving. And then we chose an ultrasonic sensor to basically detect obstacles and maneuver around it. Basically, without it, it wouldn't be able to turn right or left, essentially.
Our circuit design involves 3 ultrasonic sensors, 4 gearbox motors, a gyroscope, and the Raspberry Pi Pico board. All of our components operate within 6 volts, and our power supply is a 7.2 volt battery. Sensors and drivers were directly connected to the Pico board, while power and ground were all put parallel, maintaining constant voltage, and wired to the 3 volt out and ground pins respectively. The same will be said for each paired motor used by one motor driver board. For our program, we import pin, I2C, sleep, and library for the sensor. Motor pins are 22, 26, 27, and 28. Ultrasonic sensor pins are 2, 3, 16, 17, 18, and 19. The gyroscope was set to 0 and 1. Once configured, we define functions on certain cases. Where the ultrasonic senses something within 20 centimeters, the program will then respond. Each function involves the left and right motors acting independently if needed. For cases where the robot would turn left, it would send something to its right, so it will respond with the function turn left, where the left motors are set in reverse and right motors are driving forward. Most of our program takes a detected value and responds.
And at any time you can press the button to stop. So even if it's turning, it stops. If it's going forward, stop. Turning, stop. Forward, always turning forward. It needs to turn to the right, to the left, we'll turn left. And then go forward, and it'll keep running forward. It needs to turn to the right, do something's on the left. It'll turn right, then go forward, and then continue operation once it's clear. There's something in front, it'll turn right until it's clear.
Okay, cool.